Alright, so the way factoring by grouping works is that you have a polynomial, and from that polynomial, you might have more than one different type of GCF. Alright, so the idea is to figure out where your common factor might be coming from. Alright, so if we take a look at example 1, you can see here that if you look at the first two terms, and so I'm going to just draw a little partition here. Alright, if you look at the first two terms, you see that there's a common factor, a GCF, of x. But if you look at the second two terms, you see I have a GCF, a completely unique GCF of 7. Right? So for the first two terms, I'm going to factor out an x. For the last two terms, I'm going to factor out a GCF of 7. So when I pull out an x from here, so I divide this by x, I get a y. Divide this by x, I get a 7. Carry down the minus sign. If I take this one and divide it by a 7, I get a y. Carry down the minus. Take this and divide it by 7, and I get a 7. Alright, so this is the key step here. Once you get here, your binomials should be identical. If they're not, then maybe you need to reorganize your polynomial to begin with, or maybe factoring by grouping is not your best approach. All right, but what we can now do is take out, that's a poor quality symbol, take out a GCF, that's an entire expression here, y minus 7. All right, so we'll have a y minus 7. If I factor it out of the first, let me go green here, factor it out of this guy, it's going to leave me with just an x. If I factor it out of this one, it's going to leave me with just a 7. Carry down the sign. And what you would have here is your completely factored form. All right, try another one. All right, so we'll partition it down the middle because I noticed that I have a common r in the first two terms of my polynomial. So a GCF of r at minimum. I also have a common 4 that can be pulled out. All right, so the greatest common factor is what we're looking for. So if I divide each term by 4r, and I have 4r times m plus 2. And then for the second one, looks like I have a GCF of 3. All right, so plus 3 times, when I divide each of these by 3, I'm going to have m plus 2. All right, so now I have a new GCF, the common m plus 2. So that would come out of the whole thing, leaving me with just, really if you're withdrawing an m plus 2 from each part, so from here, if I were to withdraw an m plus 2, I'd have a 4m left over. If I were to withdraw an m plus 2 from this guy, all I would have left is the plus 3. Right, and so that's really all we're looking to do. And so those would be our factors. And you could check it by distributing. You could always check by distributing. All right. So number 3, taking a look at the first two terms again, we have a common n, so we'll pull that out. So if I withdraw an n from this guy here, I would just have an r. If I withdraw an n from this one, I would just have a plus 5. All right, again, I want to have a common binomial after I pull out my GCF. So here, this is a little tricky because I could pull out a GCF of what, 1? But is that going to help? Well, it's never a good idea to take out a 1 because it's not going to advance the cause. If I take out a -1, meaning I divide each of these terms by -1, I would get a positive r and a positive 5. That allows these two guys to match up. If you pull out a GCF, what you think the GCF is, and your two binomials don't match up, then try pulling out a different GCF because you probably pulled out the wrong one. All right, so now I have my common r plus 5. I withdrew it from the first product, so all that's left there is just the n. I withdrew it from the second product, so all that's left there is a -1. And that would be my final set of factors. All right, so the last one is kind of like the grand finale because we have a little bit of everything. So split it down the middle. We have a common, I'll write the GCF again. We have a common, well, I could pull out a 3, I could pull out a p. So 3p times, again, do your division. If you got to show a little bit more work, show a little bit more work. If I pull out a 3p, I have an n. If I divide by a 3p, same thing as pulling out a 3p. That I use those terms interchangeably. So plus 5. The other part, we have a GCF of -4. So -4, divide each of these by a -4. So n plus 5. So now we have that nice common n plus 5. Withdraw that from each part. It's gone from here, what's left? A 3p. It's gone from here, what's left? A -4. Final answer.